Hi, good evening. This is Darshan Patel. So, I had an assignment regarding my one of the subjects in data science, that is foundations of artificial intelligence, and the assignment was about making a tic-tac-toe game that is 3 by 3 grid, playable between a human and a computer. Now, the specialty about developing this assignment is making the computer a little bit more intelligent to defend and try to win the game in front of human. So we have used at, at this moment for part 1 we have used 3 by 3 matrix. I have implemented the game in using 2D array, and the developing language that I have used is Python, and the and the and the assignment is run on terminal window right now. It is not a GUI that I have developed, but it can be run on a terminal window. We can develop the same strategy on a GUI too, but part of the assignment requirement I have just developed it on to run on terminal window right now. So this is the algorithm of the code that I have developed. The O symbol represents the human player, and the X symbol represents the computer, that is the AI player, we can call it. The computer now makes a strategic moves to defend against the human player and tries to win the game. The game continues until a winner is declared or the board is full tie. The user can input their moves when it's their turn. As simple. And now one more thing I wanted to tell is, if you are using Mac, you need to just change the command of os.system clear into clear over here, as we can see. And if it is Windows, we need to do it CLS. That is the only difference if you are trying to run this code. Now let's go to the code. So this is my code. Let's start from the beginning, that is the method of print board. So print board basically prints the board, that is 3 by 3. Then there's a method of check winner, which first checks by rows and column. If any one of the matches the condition, or if anyone matches this condition, it returns true. Then if it's not in the rows and the columns, it checks the possibility of in the diagonals. If it is true, then if the criteria matches, it will return true, else false. False means there is no winner. Then we have the other one definition method that we can call it as a check tie. So here our code checks if the game is tied or not. Now over here we can again make this method more complex, more intelligent, to find whether the game is going to be tie before the whole signboard is completed. So just imagine if the computer can make out in the 7th or let's say 8th step whether the game is going to get tied or not. We can do that thing, but as per the requirement right now, I think this is much better. And moving on to the next method, that is tied. So there are some possibility there are a few possibilities where we are checking whether the game is tied or not, and if it is tied we need to execute certain things. So I just created this method because it was being repeated so much over here, so I just wanted to lessen up the lines Now we come to the main functions. Over here we have decide move method. So this method first runs through some conditions which decides whether we'll go with the win move or we'll go with the defending move. So if there's a winning move, the there's a certain one tuple with 8 returned, so we can just route our next step with a win. Over here, as you can see, we can just route our next step with a win move method. So if the decide move gets one of the condition over here from the 4, then 8 is returned. If 8 is returned, it means there's a chance where we can make a winning move. So then once return 8 is done, the computer will go into the win move and then try to make a move again in the 4 conditions over here. If the decide move method it returns 7, let's say, then we can just go over here. It will go to the if it returns 7, it means it will easily go into the else, where we can see defense move decided. So over here it goes into a get best move, that is in the get best move method, which tries to make a defensive step. So again over here we have few conditions where in any one of the move it goes, it will if it fits the situation fits into the any one of the condition, the computer will just make a move according to that particular situation. Or else, let's say if we are into the first initial steps like second or third step, and we can't match any conditions over here, then we can have one more we can have one more thing over here, that is we can say we can check for all the blank spots in the board, and then we can just randomly put anything. We can randomly enter any slot we can, because that is the only option at that point of time. If it is second move, the computer can't make out whether it's going to a certain move to win. So I just use a random choice on that particular situation, which has been successful on few, not few but many of the runs that I have made with this code. So that is all for defensive method, and this is the winning method, where the computer decides to make a move in a certain way. Then we have the method of play tic-tac-toe, which is we can say the main function like thing. So here we have a loop. We are running a loop where the computer and the human takes chances, and where you can say we have conditions over here which really navigates into a certain situation, tries to make a particular decision about what to do next. We have this few lines that are a part of user's entry. Then after all the entry, after every entry is done, whether it's a human player or the computer, we have the other section of the method that checks for the winner if the game is being tied, or let's say if nothing's going on with the winning part or the tie part, we just go on to the next player with the next move. So that was all the coding part. I hope you got it. Let's try to run it now. Okay, so this is a game where we have 3x3. Let's start with the game. Now we'll try to put 2 of 0. So here we made a move of 2 of 0, as you can see, and then the computer played their move, that is 2 of 1, last row, second column. Now let's try to block computer. We'll make a move at 1 of 1, that is the middle. So here you can see, as computer tried to know, as we entered 1 of 1, the computer knew that it is going to go diagonally. The human is going to go diagonally to make a win move. So it tried to block us over here from winning. So now let's try to block the computer, where we can just put our input over here, that is 0 of 0, first row, first column. Okay. So once we tried to make a move which was blocking the computer at 0 of 0 and also creating a move of a winning move that was on between between the first row first column and the last row first column. The computer knew there was a winning move for the human, so computer tried to make again a defensive move, as you can see, at the second row and the first column. So we have now, basically you can see we have few more slots. We can make a winning move at 2 of 2, but let's try something different. We'll just try to tie the game if possible. Okay, so computer knew there was a winning move for human, that was 2 of 2, which we intentionally didn't go for a winning move because I wanted to tie the game just to showcase the whole assignment. So we're just waiting on for the last step, that is 1 of 2, and there's a tie, right? So I think let's start with one more game. We'll try to win the game now. Okay, we made a move of in the center. Now we try to make a move at 2 of 2. Okay, computer blocks us again. We try to make a move at, let's try to win it by playing the move at last row first column, that is 2 of 0. And there you see, computer, instead of trying to block us, it better decided to make a winning move instead of a defensive move, and then it made a move at first row second column and won the game, right? So that is how I have developed my strategy. I hope you liked it. I'll try uploading this code on the GitHub too, and I hope you have liked the assignment that I have done. So if there's any confusion regarding the code, you can go over to my PDF, where I have written a short algorithm about what exactly the code is doing, and you can contact me for furthermore for any complexity in understanding. That's all. Thank you. I hope you liked it.